Okay, so welcome back to EnergyPlus for beginners. In this video, I will show you how can we model the ground and the contact, the interface of the building with the ground. So there are basically two ways, two types of modeling the interface of the building with the ground. The first one is using the average temperature of the ground, and the second one is using a ground domain uh, approach. In this video, I will show you how can we use the ground domain approach, which is more accurate to represent the heat exchange between the building and the ground. So there are three methods of calculations to model the ground domain approach. First one is the finite differences, the second one is Kusuda-Achenbach, and the third one is Ching. Each of one of these different methods of calculation uses a combination of different objects in EnergyPlus, and in this video I will show you how can you use finite difference method, and you can use like a similar approach to reproduce another like Kusuda, Achenbach, or Ching method as you wish. Once you have chosen your method of calculation, you also have to understand what is the condition of your slab. So what is the position of your slab of your building? The slab could be in grade, which is represented by this figure here on the left, or can be on grade, which means the slab, which is the element of the building that is in contact with the ground, is above the ground or it is inserted on the ground. So depending on the approach that you consider, the heat exchange will change. So these figures were extracted from the engineering reference of the EnergyPlus documentation. Okay, so once you have decided of the approach and the calculation method, let's go and see on EnergyPlus how can we model the ground and the heat exchange with the ground. So I have this EnergyPlus model here, okay, and if you see in building surface detail, we have this object, floor thermal zone 1, which is a floor, so it has a interface with the ground. Okay, so what we want is to change this outside boundary condition attribute here, represented by now is the ground. What we want is to set other side conditions model. So basically we are telling EnergyPlus that we are modeling the outside boundary condition of this floor as another special thing that we are going to set up. So let's set up the other side condition model. Okay, so to do that, let's press Ctrl L and let's find an object called site ground temperature undisturbed finite difference. And let's create an object here. Here we are going to create an object to represent the ground. So let's call it ground. And we need to set some thermal properties for this ground. So let's set just like generic thermal properties. Is going to depend on your ground thermal properties of the location that we are building. Okay, I'm just setting some thermal properties generic. Now we're going to find another object called site ground domain slab. So this was the ground and this is the slab. Okay, so let's create an object here and let's call it slab. Okay, so now we have a lot of properties, and what we want to set is the undisturbed ground domain model type. Let's see if it is which type of calculation it is. It is Kusuda, Achenbach, Ching, or finite difference. We are using finite differences. Okay, and what is the undisturbed ground temperature model name? Is the one that we already created. It's our ground. And now we need to set the slab boundary condition model name and the slab condition. Okay, the slab boundary condition model name we are going to create on the object called other side conditions properties. Let's find a class called other side condition properties. Here, surface property other side condition model. So let's create an object here and let's call ground domain. Now the type of modeling that we want to set is ground coupled surface. Okay, so this is the type of the other side condition model that we are setting. So let's go back. We can press Ctrl L now. Let's go back to our site ground domain slab class, and here we can now find our slab boundary condition model name, which is ground domain, which is created, and the slab location, which we're going to choose between in-grade and on-grade. This is a generic example, but I'm just going to assume that it's on-grade. Okay, now we set the other side condition model. So all we have to do is to go to our building surface detail, find our floor, and here the outside boundary condition, it's already set at other side condition model. And now we have to connect this surface with the other side condition model that we create. So we are going to do that by setting the outside boundary condition object to the other side condition border object that we created, which is the ground domain. There it is. You have your floor model according to the ground domain approach.